If you're a beginner at soldering in electronics assembly and you're beginning to assemble this project, I think the best place to start is with these orientation sensor boards. You need 7 of these, and the only thing you have to do is to prepare them for the rest of the assembly is to solder them to these header pins which come with the boards. These are going to be used to attach the orientation sensor board to the custom PCBs and the other boards in the project. Again, strips of these come with the board, and they're very easy to break apart into the number that you need. You can see they have those grooves there. You can snap them apart with your hands, or better yet, with a small pair of pliers. And so for this, you're going to need a strip of 4 and a strip of 6. And what I've done is inserted them into a breadboard by inserting their long side, right? See, they have a short and a long side. I insert the long side into the breadboard. And this is just a regular old assembly breadboard with prototyping breadboard with a 2.54 millimeter or 0.1 inch spacing. And so you just put those in there, and so that the separation between them matches the separation between these holes on the board. And then when you insert them, you can see that now they're held in place for soldering, and they'll be, furthermore, they'll be at 90 degrees to the board when you're finished. Now that I've got that done, I'm going to zoom in a little bit so that we can see this a little bit more clearly. And off camera, I'm cleaning my iron just with a wet sponge. You can use the wet sponge or the brass turning sponge, whatever you prefer. And I'm going to bring in and come in and solder these pins. Now I've got a fine chisel tip on here. This is a Hakko iron. It's a nice inexpensive brand of soldering station. And I think the fine chisel tips are the best for this, or chisel tips in general the best for this, because they hold more solder. This is probably a little too fine for this technically, but it's what I have on here. What you want to do is come in with the clean tip and heat the pad and the pin simultaneously. So you want to stick the tip of your iron kind of down in between them like that. Okay, and you'll see that very quickly they will heat up enough to melt the solder. So I'm right-handed, so I've got the soldering iron in my right hand and the solder in my left. And I'm just going to come in and briefly heat this, and then let the solder melt around and flow around the pad like that. Okay? And when it flows around the pad like that, what you're doing is assuring that it's joining to that metal by capillary action, or I'm assuming it's a similar physical phenomenon. And that assures that the solder is intimately joined to the surface of the metal and making good electrical connection. The alternative is what we call a cold solder joint, where it's basically just sitting on top of the metal and not actually in intimate contact with it. So let's try again. There's another one. Let me zoom in a whole lot more for that third one so that you can see it more clearly. And there you go. And when I'm done, I'll pull this off and show you that when you allow the solder to flow around like that, it'll form a convex fillet along the length of the pin. And that's a good indication that you certainly do not have a cold solder joint. I've got the soldering iron in my right hand, but I also don't want to come over the chips with the soldering iron, just to avoid inadvertently heating something. Probably a momentary heating wouldn't hurt anything, but you wouldn't want it just kind of laying on those chips. Now you'll notice that little bit of smoke coming out when I solder these. That's the flux core inside the solder. So you don't need to add extra flux if you're using flux core solder. As you'll notice throughout this series of building videos, I will be adding flux along the way at some point. And what I'm adding is this. This is no clean flux. The label's worn off, so you can't see it where it says no clean, but Kester flux pen, no clean flux. And what that means is if you forget to clean the flux off, it's not going to degrade the board over time. I do typically clean them with isopropyl alcohol, If the board is not powered, you can clean it with isopropyl alcohol to get the extra flux off, and it won't hurt anything as long as you let it dry out before you put any power to it. So now I'm going to turn this. I'm just lifting. I've got this, I didn't mention, but I've got this breadboard double stick taped down. That's really all it takes to secure it. Occasionally you have to bend your solder to get around obstacles so it comes in at a good angle. Okay. All right, so let me quickly pull this off of the breadboard and show you what those fillets look like. So you can see I've got convex fillets of solder running up the pins where I soldered them. And that's not necessary for electrical connection, but it is a good indication that you do have a good solder joint, not a cold solder joint. So again, you have to do 7 of these. So that's a lot of practice before you do anything else. So you can go ahead and put the pins on all 7 of your sensor boards. Now, what you want to do when you're done with that is take 2 of your sensor boards and separate them from the others, because these are going to be for the ones for the hand and the foot. And what you want for the hand and the foot, you want to go in and bridge this joint right there. Okay, so I'm going to go ahead and do this now. So it's very easy. I'm just going to take a little bit of tape just to quickly hold this in place. Doesn't have to be held very strongly. And this will be an opportunity to use the flux, because I'm going to be applying a lot of solder directly to the surface of those, and so a little bit of flux will help with that. So to bridge a solder, this is called a solder jumper, and to bridge one, all you do is put some solder on one pad, put some solder on the other, and just keep adding more until they flow together. Super easy, right? Only takes a second. Now what we've done there by closing that solder jumper is change the I2c address from hex 28 to hex 29. These 7 different orientation sensors only have 2 available addresses. That's why we have to use those serial switches along the way to choose between them. The forearm and the hand and the foot, or the foot and the leg, they are on the same bus, and so we have to adjust their address. So that's why we do that. So you just do that with 2 of these. One's going to be for the hand, the other's going to be for the foot, and just put them aside so that you don't mix them up with the others, because it'll be really hard to fix that if you accidentally solder this one into, for example, the one for the femur or the humerus. Right? So just put them aside so you don't get them mixed up with the others. So next I want to work on soldering the headers onto these I2c Multiplexer Modules Tca9548a. You need 3 of these, 1 each for the arm and femurs, and then 1 for the main board assembly. What I'm going to show you here is the one for the arm or femur. They're the same. You assemble them the same for the arm or the femur. And the first thing you want to do before you begin is, if you look on the back here, there are some pads that say cut to disable pull-ups. And what I've already done is gone in with the utility knife and cut a thin conductor that was between these 2 pads. Okay, and what that does, you want to make sure that's completely cut. You can use a continuity tester to confirm if you wish. What that does is disable the connection to these pull-up resistors that are built into this board. And if you don't do that, then those pull-up resistors will be in parallel to the ones that we're going to add on the boards for the arm and femur, which are designed, the value was chosen to help with the speed of that long bus for the long length of wire going down the arm and femur. Okay, so make sure you cut those first. So now that I've cut the traces to disable those pull-up resistors, I now can put some header strips into this breadboard to hold this I2c multiplexer module for soldering. And I've got a set of 4, a set of 2, a set of 2, and another set of 4, but in this one I've pushed one of the pins out. And so if I go ahead and put that last one in place, now if I can put the board on here in place for soldering, and you can see we've got occupied here VN, ground, SDA and SCL, that's the main inputs to this board. A0, that's going to help us set the I2c address for this one. We've got over here SC6 and SD6, that's channel 6, and SC3 and SD3, that's channel 3. Those are the ones we're using. These two over here, A2 and SD0, are not connected to anything, but we're using them to just, mechanically support this board. Okay, so now the same idea as before, we can clean the iron. You can use a brass sponge or a wet sponge, it doesn't really matter. And we're going to go ahead and just do the through-hole soldering here, just as we did before, making sure that we wet all the surfaces with the solder. All right, that should do it. And maybe to show you a little bit more about what I mean by the shape of the fillet, just zoom in on one of these, and you can see that there's the kind of a convex slope to the iron, to the solder as it runs up that pin. Let me focus a little bit. Yeah, so you can tell that the solder has kind of crawled up the pin by capillary action, or I'm not sure what the physics of it is, but it's evidence that the surface is fully wetted with the solder. Okay, now let's put together the I2c multiplexer board that's going to go with the main module. This one is connected differently, and it's also, one other difference is that we're going to leave these traces intact on the back. So we're going to leave the pull-up resistors intact on these, or the trace for them. I do have on the main board a place for some pull-up resistors, but I don't populate those. I put those on there in case I wanted to adjust it at some point, but hasn't proved necessary. So if we just leave these two traces intact, then the built-in pull-ups on this board will work fine for us. I've also prepared the breadboard with some headers. Once again, I got a set of 4 here, set of 4 there, set of 2, and then this is 3, but I've got them on a strip of 5, and I've removed 2 there. So it's 1 blank blank and then 2. So now if we put the I2c multiplexer board on this, we can see we've got, of course, the main inputs, power, ground, and the main I2c bus input. And then we've got A2, so we can adjust the address for this particular chip. And then we've got the channel 1 bus, the channel 7 bus, the channel 6, and the channel 2 bus down here occupied. Okay, so go ahead and clean my iron. And put this together. All right, that'll do that one. Okay, so in terms of getting the microcontroller board ready to be part of the main module, there's not a whole lot we have to do. Now this is a ESP2866 microcontroller with built-in Wi-Fi, and it has a lot of pins and possibilities and connections here, but we're not actually going to use very many of them. Basically, most all the data that comes in through this thing comes in through the I2c bus, and we only need 2 pins for that. We are going to use some pins to control the power IC, the high side low switch that's on the main board, and of course then we also need some we need ground and power, and we need also to maintain the mechanical stability of this board. So you can see we're not using that many. We've got battery and enable here. We've got pins 16 and 2. Over here we have pins SEK, MO, and MI. And then here we've got NC, that's not connected, and then the ground pin as well. So that is going to be the ones that we're going to use, and it's the same procedure that we did before. We've got it mounted on a breadboard to keep the pins parallel, and I'm just going to solder them in. All right, so there it is, ready to go. All the pins that are needed are soldered on.